Hey, Jonathan here at Colfax Math. In this video, I'm going to go over the Praxis Middle School Mathematics sample test, and I'm just going to kind of work my way through some of the problems with the camera over my shoulder so you can see how I do them. You could get these practice problems at ets.org/praxis/prepare. This is a middle school mathematics exam, and these are only some of the sample problems on test 5169. Laminated overnight on a CNC. Jonathan here. This is the Praxis Middle School Mathematics exam 5169, and you could get this practice exam at ets.org/praxis/prepare. And I'm just going to work my way through this test, starting on, there are 15 problems here. And I'm just going to show you how I kind of figure them out. Hopefully it'll be helpful. I will read this disclaimer right here. I know it's a little bit small, but it says, these are sample questions that illustrate the kind of questions on the test. They are not, however, representative of the entire scope of the test. So this is really just to get you a feel for it. And what I would do is I would print that test out, do the problem first, and then see how I solve it. And your solution might be better than mine, but my answers are checked against the actual key to the test. So I'm just going to kind of run through how I do it. I do mark up the test as much as possible, underlying key ideas, showing all my work. And if I do take the test online, I make sure I have scratch paper so that all my work is there. It allows me to go back and check my work. And additionally, it's a lot less likely to make careless mistakes if you write out all of the pieces. So if you're taking it on a computer, make sure you label your problems, write out the key ideas, and go slow enough that you don't make any careless mistakes. Remember, the hardest problem on here has the same weight as the easiest problem. So you don't want to rush through the ones you could solve to get to one that you might not know anyway. So go slow, be deliberate, and hopefully this will help. Okay, so problem number one, it's a multiple choice, 4 possible answers, and I'm trying to kind of key off what is it that they're actually trying to test me on here. So Anne plans to place a continuous wallpaper border on the walls of her living room, shown above. Each roll costs $6.47. That's a key number. And no partial rolls are sold. So that right there tells me this is probably more about rounding than anything. If each roll is 8 feet, what's the minimum amount she can spend on rolls? We'll have to figure out the perimeter of this drawing. 12 plus 18 is 30 times 2. So it's 12 plus 18 plus 12 plus 18 is 60 total feet. I do 60 feet divided by 8 feet to get the number of rolls. That's going to be 7.5, so I'm going to round up to 8 rolls. And then I'm going to take 8 rolls and multiply it by the dollar amount, 647 times 8, to get 56, 32, 37, 48, 51. So the total she spends is $51.76. Okay, on number 2, the original price of a certain car is 25% greater than the cost to the dealer. So I think I'm going to say this is the cost to the dealer, and then this is my original price. The actual selling price is 25% less than the original price. So this is my selling price. So the actual cost of the car to the dealer I'm going to call 100. The original price is 25% of the cost to the dealer. So this is going to be 25% of that. 25% greater, so this is 125%. The actual selling price is 25% less than the original price. So this selling price is 25% less than the original price. So this is going to be 75% of this 125%. All I'm really doing here is converting the paragraph into kind of a chart. If C is the cost of the car to the dealer and P is the selling price, so selling price is P, which of the following represents P in terms of C? So I want 125% of 100. So 125% of the cost is right there, and then that times the selling price. So kind of the key to this problem is really just kind of analyzing these words and turning it into a chart. So I see it's 125% of C and then 75% of that total cost. So P is going to be equal to 75% of 125% of that cost. So the answer to 2 is D. Okay, let's look at number 3. 3 is the same thing. It's really kind of decoding the paragraph. So on number 3 here, I have a list of K, but there are no numbers in that list. I mean, it's not shown. Is greater than 75, so let's say 76, 77, they're integers, so the whole number. List M consists of the integers in list K, so it consists of these, 76, 77, and so on, and 4 additional integers that are less than 75, so 74, 73, 72, and so forth. Which of the following statements could be true? So they don't have to be true. The key thing here is could be true. The mean of the integers in M, mean is the average represented with x bar, so it's the sum of all the values divided by the number of values. The mean of the integers in M is 75. Yeah, that one and that one could couple together to give you 75. That one and that one could couple together to give you 75. That one and that one could couple together, so A is true. The median is a middle value, so that's my middle value there, could be 75, that could be true, so that's true as well. The mode is the most frequent value, so the mode would be like if I had a bunch of 75s, which I don't. So the mode is 75 is not true, but A and B are true. Okay, jumping down to number 4 here. Parallel lines cut by a transversal, denoted parallel with usually double arrows on there, or told that you're parallel. So here they say they are parallel. This is x degrees, this is y degrees. So I know that this angle and this angle are a linear pair, meaning that these two angles add up to 180. This angle and this angle are corresponding angles, so those two angles are congruent. So that means x and y together, x plus y has to be equal to 180. And then I also know right here that y is equal to 3x. So I take that value of y and I plug it in for y, and I get x plus 3x equals 180. 4x equals 180. Divide both sides by 4, and I get x is equal to 45 degrees. So 4 is B. Okay, I'll give you a second to try and do number 5 there. So on number 5, before I even look at it, I'm trying to figure out the strategy. The solutions are all on a number line. I'm looking at this and I'm thinking, I know an inequality, the issue with the inequality is when you multiply or divide by a negative, you reverse the sign. So that's what this thing's testing. So on number 5 here, I have negative 4x plus 1 is greater than or equal to 21. I subtract 1 from both sides to get negative 4x is greater than or equal to 20. Divide both sides by negative 4. This gives me x by itself. I am dividing by a negative. I flip that thing around. X is less than or equal to 20 divided by negative 4, negative 5. Equal to is a colored in dot. So it includes, this is inclusive of negative 5, and that's inclusive of negative 5. That would be just less than. That would be you did not understand to flip that when you divide by a negative, same with that. So the correct answer for 5 is A. All right, turn in the page. Give you a second to read through this one, number 6. So C is the largest, B is the next largest, A is the next largest, but they're all greater than 0. These fractions, are you trying to figure out which one is the largest and the smallest? You could do a lot of thinking here and make it complicated, or you could just assign numbers here. Let's say A is 1, B is 2, C is 3. So that means C over B would be 3 over 2. C over A would be 3 over 1. A over C would be 1/3. A over B would be 1/2. So I'm arranging them from least to greatest. 1/3 is the smallest. 1/2 is next. A over B. This is 1.5 and 3. C over B. And then C over A. C over A. So that's the way I would do that one. Not too hard. Okay, number 7 here. The graph above shows the distribution of contents by weight of a country trash. 60 tons of paper. So this is equal to 60 tons. So 40% of all the trash is 60 tons. How many tons are plastic? Well, plastic is 8%. So 8% is how many tons? Well, to go from 40 to 8, I divide by 5. So to go from 60 to this, I'll divide by 5 as well and get 12 tons. So the correct answer here is D. Okay, number 8, if a student on number 8 here, I'll give you a second to do that. I know it's hard to read. The student takes a test consisting of 20 problems. So there are 20 true-false problems. Randomly guesses at all of the answers. What's the probability all 20 will be correct? So the likelihood of getting one right just randomly would be 1/2. And then means to multiply or means to add. So you'd have to guess on the first one, and then the second one, and then the third one, and then the fourth one, and then all the way across. So that would be 1/2 times 1/2 times 1/2, or 1/2 to the 20th power. So number 8 here is A. Okay, number 9 here. I'm given this equation 3x plus 2y equals 8. And then I want to know if the lines intersect or parallel. This basically, the graphs of the lines will never intersect. That would be when they're parallel. The graphs intersect once. That would be when their slopes are not equal. And then when they coincide, that would be sitting on top of each other. So they'd have to be the same equation. I do notice something between my given equation right here, 3x plus 2y equals 8, and this right here, negative 12, that's times 4. So if I multiply this by negative 4 on both sides of the equation, it gives me negative 12x, negative 8y, negative 32. Those are the exact same lines. This line and this line are the same, so they coincide. The next equation here, I'm going to start with 3x plus 2y equals 8. The next one is 9x. I'm going to multiply this by 3 to get 9x plus 6y. Right, I got to multiply everything by 3 equals 24. So they actually are not the same equation. So these things are going to intersect once. The slopes are going to be different. So they're going to intersect once. Slope is rise over the run. Then on the third equation, I have 3x plus 2y equals 8. To get here, I can multiply by a negative 2 to get negative 6x minus 4y equals negative 16. Those are going to intersect once. Yeah, those are going to intersect once. And then right here, get from 3x to 18x, I'm going to start with my same equation, 3x plus 2y equals 8. How do I get to 18x? I'm going to multiply both sides by 6. Get 18x plus 12y is equal to 48, negative 48. These two have the same slope, right? They have different y-intercepts, but they have the same slope. So these lines right here are parallel. So just a quick review on slope. A good way to look at it is y equals mx plus b, where m is your slope. So if I got it in that form, m is equal to rise over run. If they had equal slopes, they would be parallel. If they had dissimilar slopes, they would intersect once, and if they were identical equations, then they would coincide with each other. So that's that equation, or that's problem number 9 there. Moving on to number 10, again trying to figure out, what's the point of the question. Which of the following graphs in the xy plane is a function? The way you tell whether something's a function is a vertical line test. You draw a vertical line on it. If it only crosses it in one place, yes, it is a function. So this is a function. If it crosses it in more than one place, it is not a function. So this is not. So these are all non-functions, and only A is a function. The reason why these are not functions with the vertical line test is the definition of a function is given an independent variable x, there is only one corresponding value of y. So here, let's say x is equal to 2. What's the y value? Well, it could be that y value or that y value. So there are multiple solutions to one independent variable. So this is not a function. So 10a is the only function there. Number 11, I have a parabola going through the point -5. So over 0 up -5. And the quadratic equation, y equals ax squared plus c. What is the value of c and a? Well, c, this value right here, is where it crosses y-intercept. So I have y equals ax squared minus 5. Now I need to solve for a. So if I could find a coordinate and plug it in for x and y, I could solve for a. So this is a pretty clear coordinate there. So that coordinate is over 2 up 3. So this is a xy. So when y is 3, x is 2. Now I have one equation, one variable. 3 is equal to 4 times a minus 5. Add 5 to both sides. 4a equals 8. And a, divide both sides by 4, a is equal to 2. So the value for c is -5, and a is 2. Hopefully that made some sense there. Let's see here. So up above, in triangle ABC above, AB is 21, so I'm just going to transfer my information to the diagram. AB is 21, AD is 15, DE is 12, AB is parallel to DE, so these are parallel lines. What is the value of AC? So what is the value of AC here? So this is actually what I'm looking for. Because they're parallel lines, it's like they're cut by a transversal, so all these angles are equal, so it's going to create similar shapes. Parallel lines cut by a transversal. These angles are congruent, these angles are congruent. So that means the proportions have to be the same. I don't know what this is, so I'm going to call it x. I know this to this is the same as this to this, right? So 12 is to x, 12 is to x, as 21 is to that long length, 15 plus x. One ratio equal to another is proportion. I cross multiply. 21x is equal to 12 times 15 plus x. I want to forget to distribute here. 21x equals 180 plus 12x. All my x's to one side. 9x equals 180. Divide both sides by 9. And x equals 20. I'm sure that's a solution. It's A, deliberate distractor. This is 20. The correct answer is, what's the value of AC? AC is 35. So part of the reason I marked this up is so I don't make that mistake. So I did solve for x, which is 20, but I'm looking for the overall length. Okay, it's getting a little bit long here. The graph of the linear function passes through these points. What is the slope? Again, slope is m, and y equals mx plus b. And m, slope, is rise over the run. Rise is going to be the change in the y values on the Cartesian coordinate, right? Y. And it's going to be divided by the run, the change in the x values. So rise is going to be -4. -4 minus y2 minus y1 minus 11 divided by 7 minus -3. It's going to give me -15 over 10. So -15 tenths. That's a reducible fraction. 5 will go into there 3 times, into there twice. So my solution is -3 over 2. Hopefully you're pausing the video and doing these problems first, and then just watching the way I go through them after that. Okay, number 14, coming to an end here. Determine which net below can be used to form each solid, then click and drag. So a net is like a broken down box, and if you were to fold it up, it would give you a solid. So if I folded this side up, this side up, this side up, and then fold them around, this one right here will give me a cube. This is a pyramid, a square base pyramid with these triangles fold up to give me a pyramid, a square base pyramid. So this one will go to there. This is a tetrahedron. It's a pyramid with a triangular base. So as these fold up there, it would come to this. And then this one right here is like a tent. This is actually a triangular prism if you turned it on end. So this one would go there. Kind of spatial recognition. I kind of like these problems. Okay, and then lastly, number 15, what is a units digit of 3 to the 43rd? I think this is actually a pretty hard problem. You can't enter that on your calculator because it's too large of a number. This is actually a sequence and series problem. I don't know how you'd recognize this. This is hard. But if I'm going to have, let's say, n, 3 to the n, so let me set up a chart here. If n is 0, 3 to the 0 is 1. If n is 1, 3 to the first is 3. If n is 2, 3 squared is 9. 3 to the third is 27. 3 to the fourth is 81. And I'm looking at the units digits. So I'm looking at the last digit. So I'm starting to see a pattern here. 1, 3, 9, 7. 1. Let's try this. 5. 3 to the fifth is 243. 6. 243 times 3. What is that? 727? No. 243 times 3. Actually, it doesn't even really matter. I'm just looking at the ones place. 729. So I see 1397, 1397, right? Because if I multiply this by 3, I'd be back to a 27. If I multiply that by a 3, I'd be back to a 1. Multiply that by a 3, I'd be back to a 3. Times 3 is 9. Times 3 is 27. So I could see a pattern here. So if n is 0, I get 1 in the ones in the units place, and then it repeats every 4 times. So this is a repeat every 4 times. 3 to the 43rd is 4 times 10, and then it's going to be 3 to the 3rd, which will be 27. So the correct answer for this would be a 7. It's kind of a hard problem on sequence and series. I don't know if that helped, but hopefully me going through this test helped. This is Jonathan at Colfax Math. I appreciate you watching these videos. If it did help, hit like. I'd like to hear your comments below, how you did on this test. I appreciate you watching, and if you like, applications of math, if you're going to be a middle school math teacher, I highly commend you, because it is a wonderful career. I can't imagine anything better than teaching school. So hit subscribe if you want more videos like this, and I appreciate you watching. Thank you.